A differentiable function is a function whose derivative exists at each point on its domain. The graph of a differentiable function must have a non-vertical tangent line at each point in its domain. As a result, the graph of the differentiable function must be relatively smooth and cannot contain any breaks, cusps, or any points of vertical tangent. Here's an example of what a differential function looks like. Okay, and the primary reasons why this is a differential function is because it's continuous, and at every point on this line you can take a derivative, as well as every point on this line has a defined slope. Let's take this point for example. Coming from both sides, it has a defined slope at this point that both sides meet. And it's also a continuous function because both sides meet at the exact same point on the line.
Alright, now we're going to show you some graphs that aren't differentiable. Okay. This is a corner. This graph is not differentiable because at this point there are two different slopes. One coming from this side is different than the one coming from that side, therefore rendering this point not differentiable. Boom. Okay, this is a cusp. This is similar to the last example because, again, at this point there are two different slopes coming into the same point, therefore also making this graph not differentiable.
Okay, so in a graph that could perhaps look like this, where both lines approach the same x value, they have different y values and are approaching different points, which makes it discontinuous and also not a differential function. Let's go. Okay, another example where a line would not be a differential function is one that looks like this. And the reason why it's not a differential function is because at points on this line, the slope is undefined, which basically means it's going to either negative infinity or infinity, so you can't define the slope, and that's why it's not a differential function.
Alright, so for this piecewise function on the left side of the graph from negative infinity to 0 we have y equals x squared, and then from 0 to positive infinity we have y equals x. So to figure out if this is differentiable or not, all we have to do is take the derivative of y equals x squared, which is just 2x, and the derivative of y equals x, which is just 1. And then all we have to do is plug in the point 0 for x. So 2 times 0 equals 0, and 1 is just 1. So clearly these are not the same, and therefore this is not differentiable. Alright, so this function here, for every x value there is a defined point. So from negative 3 to 0, all these points along here have a defined slope until you hit x equals 0. And because of the discontinuity here, none of these points, this one, or this one, are differentiable. Then continuing on from here, as soon as you leave x equals 0 and start continuing back on this line, all these points have a defined slope until you get to the end of the domain at x equals 3. Okay, for this piecewise function we have root x, which is differentiable by itself, and 2x minus 1, which is also differentiable by itself. They meet at x equals 1, so we need to test that and see if they have the same slopes there. So the derivative of root x is 1 over 2 root x, and the derivative of 2x minus 1 is just 2. So then we plug in the point 1 into both of these. So 1 over 2 root 1 equals 1/2, and then 2 just equals 2. And as you can see, 1/2 and 2 do not equal each other, so therefore this function, or this piecewise function, is not differentiable.